Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic we're going to cover the angle between vectors. So, in this topic, we will define the angle between two vectors, look at some examples, and consider an application. Now, in a previous lecture where we were introducing vectors, we deduced from first principles, that is, from the definition of the trigonometric functions, that cosine of theta was equal to what we now call the inner product over what we now call the 2 norm of u multiplied by the 2 norm of v. We actually showed that this was true for two-dimensional real vectors. Now, we have seen the Cauchy-Bunyakovsky-Schwarz inequality for all inner products and their induced 2 norms, and we know that this is now true. Consequently, we may deduce that the inner product is bounded between the negative product of these 2 norms and the positive product of these 2 norms. If u and v are non-zero vectors, then we can divide by those 2 norms to get that this ratio is bounded between -1 and 1. Well, if these values are indeed, if this ratio is indeed bound between these 2 values for all vectors in all vector spaces, then for an arbitrary vector space, we will simply define cos theta to be this ratio. Now, the arc cosine function returns a value on the interval from 0 to pi. If theta is equal to 0, then u and v are positive scalar multiples of each other. If the angle we calculate between 2 vectors is between 0 and pi over 2, then we'll say that u and v point in approximately the same general direction. If theta is equal to pi by 2, then u and v are orthogonal. If theta is between pi over 2 and pi, then we will say that u and v point in approximately opposite directions. And if theta is equal to pi, then u and v are scalars that are negative scalar multiples of each other. So, let's consider these 2 vectors again. Their inner product was 56. The one norm was 5. The other norm was 13. Therefore, cosine of theta is equal to 56 over 5 times 13, which is 65. Well, if we evaluate this, then we see that theta is approximately 0.5325 or 30.5 degrees. Now, let's consider these 2 vectors. The inner product, as we calculated before, was -16. The 2 norm of the first is 3, the 2 norm of the second is 7, and therefore cos theta is equal to -16 over 21. Therefore, theta is equal to approximately 2.437 radians, or just shy of 140 degrees. So these 2 vectors point more in opposite directions than not. Now, consider these 2 vectors here. The inner product between these 2 vectors was found to be -42. The 2 norm of the first vector was found to be root 14, while the 2 norm of the second vector was found to be root 126. Therefore, cosine theta is equal to -42 over the product of these 2 roots, which is 42. Therefore, theta is equal to pi or 180 degrees. And therefore we deduce that these vectors are negative scalar multiples of each other. U is equal to negative 0.5 times v, and v is equal to negative 2 times u. Now, consider these two vectors. We calculated the inner product to be this sum of products, which we found to be equal to 0. Therefore, we really don't have to calculate the two roots, the two norms, because cos theta is going to be equal to 0, and therefore the angle between these two vectors is pi by 2, or 90 degrees, hence being orthogonal. Now, if 2 points are known to be on the surface of a circle in R2, a sphere in R3, or an n-dimensional ball in R to the n, and the radius of that ball is r, and if we calculate the angle theta between 2 points, then the angle between those 2 points times r is the distance between those points along the surface of that ball in r to the n. So, for example, the radius of the Earth is 6,371 kilometers. The latitude and longitude of Ottawa are given here as 75 degrees west and change and 45 degrees and change north. From this, we can calculate the absolute position, assuming the positive x-axis goes from the origin and passes through the equator along the Greenwich meridian. The z vector or axis goes from the center of the Earth towards the North Pole, and you can use the right-hand rule to determine where the y-axis is. Also, we can calculate the position or the absolute coordinate relative to this coordinate system, the location of Mecca, which is at 39.49 minutes east, 21 degrees 25 minutes north, which is again approximately this location given here. Those are 2 points that are on the sphere, at least approximately. Now, calculating the cosine of the angle between these two vectors, we have the inner product of the two locations in the numerator and the norms of these two vectors in the denominator. And of course, the norm of each of these is the radius of the Earth. This we can calculate to be approximately negative 0.02114, which means that Ottawa and Mecca are slightly more than 90 degrees apart. We can actually calculate theta to be approximately 1.5919 radians, and therefore the distance between Ottawa and Mecca, if you were to travel in a straight line on the surface of the Earth, that would be that radian multiplied by the radius of the Earth, which is approximately 10,142 kilometers. All right, in this topic, you now know the definition of the angle between two vectors. You have seen a few examples, and you now understand an application of this angle for calculating distances between points on, for example, the surface of a sphere. Here are the references, acknowledgements, colophon, and a disclaimer. Cheers!